In this video, we're going to focus on geometric sequences and series. So first, let's discuss the difference between a geometric sequence and a geometric series. What do you think the difference is? Here's an example of a geometric sequence. The numbers 3, 6, 12, 24, 48, and so forth. A geometric sequence is different from an arithmetic sequence, such as this one here, in that a geometric sequence has a common ratio versus a common difference. If you take the second term and divide it by the first term, 6 divided by 3 is 2. You're going to get the common ratio. If you take the third term divided by the second term, you'll get the same common ratio. 12 divided by 6 is 2. So that's the defining mark of a geometric sequence. In an arithmetic sequence, there's a common difference. If you take the second term and subtract it from the first term, 8 minus 5 is 3. If you take the third term subtracted by the second, 11 minus 8 is 3. So that's how you could distinguish an arithmetic sequence from a geometric sequence. An arithmetic sequence has a common difference between terms. A geometric sequence has a common ratio between terms. Within an arithmetic sequence, you're dealing with addition and subtraction. For a geometric sequence, you're dealing with multiplication and division between terms. So now that we know what a geometric sequence is and how to distinguish it from an arithmetic sequence, what is a geometric series? A geometric series is basically the sum of the numbers in a geometric sequence. So 3 plus 6 plus 12 plus 24 and so forth would be a geometric series. This is the first term, this is the second term, this is the third, and so forth. Now the formula you need to calculate the nth term of a geometric sequence or series, it's the first term a sub 1 times the common ratio r raised to the n minus 1. So for instance, let's just make a note that r is equal to 2. Let's say we want to find the value of the fifth term. We know the fifth term is 48, but let's go ahead and calculate it so you can see how this formula works. So the first term is 3, r, the common ratio, is 2, and n is the subscript here. We're looking for the fifth term, so n is 5. So 5 minus 1 is 4. 2 to the fourth power. If you multiply 2 4 times, 2 times 2 times 2 times 2, that's 16. 16 times 3 is 48. So that's the function of this formula. It gives you the value of the nth term. So you can find the value of the 8th term, the 20th term, and so forth. The next equation you need to be familiar with. Well, first let's get rid of this. The next equation is the partial sum formula. The partial sum of a geometric series is the first term times 1 minus r raised to the n over 1 minus r. So let's say that we want to find the sum of the first 5 terms. This is going to be 3 plus 6 plus 12 plus 24 plus 48. Go ahead and plug that into a calculator. So for the first 5 terms, I got the partial sum as being 93. Now let's confirm that with this equation. So let's calculate s sub 5. The first term is 3 times 1 minus r. R is 2, n is 5, divided by 1 minus r, so that's 1 minus 2. 2 to the fifth power, that's 32. 1 minus 2 is negative 1. Now 1 minus 32 is negative 31. 3 times negative 31, that's negative 93, but divided by negative 1, that becomes positive 93. So we get the same answer. So anytime you need to find the sum of a finite series, you could use this formula. So this series here is finite. We're looking for the sum of the first 5 terms. There's a beginning and there's an end. This series here is not finite, it's an infinite geometric series. The reason being is because of the dot 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 that we see here, it goes on forever. It doesn't stop at the 5th term. It keeps on going to infinity. So it's an infinite geometric series. This is an infinite geometric sequence. It's a sequence that goes on forever and it's geometric. So make sure you can identify if a sequence is arithmetic, geometric, is it finite, infinite, is it a sequence or a series? Now the next thing we need to talk about is the arithmetic mean and the geometric mean. Let's call the arithmetic mean MA. The arithmetic mean is simply the average of two numbers. The geometric mean, let's call it MG, is the square root of the product of two numbers. So let's go back to the arithmetic sequence that we had here. If we wanted to find the arithmetic mean between the first and the third term, it will give us the middle number, the second term. If you average 5 and 11 and divide by 2 using this formula, you're going to get 16 over 2, which is 8. So thus, when you find the arithmetic mean of the first term and the third term, you're going to get the second term because the average of 1 and 3 is 2. Now, let's find the arithmetic mean between the first and the fifth term. This will give us the middle term, 11. So if we were to add up A1 and A5 and then divide it by 2, if we were to get the average, we would get A3. The average of 1 and 5 is 3. So let's add 5 and 17 and then divide by 2. 5 plus 17 is 22. 22 divided by 2 is 11. So that's the concept of the arithmetic mean. Whenever you take the arithmetic mean of two numbers within an arithmetic sequence, you get the middle term of those two numbers that you selected. Now the same is true for a geometric sequence. If we were to find the geometric mean between 3 and 12, we would get the middle number 6. If we wanted to find the geometric mean between 3 and 48, we would get the middle number 12. So let's confirm that. Let's find the geometric mean between A1 and A3. So the first term is 3, the third term is 12. 3 times 12 is 36. The square root of 36 is 6. So we get the middle number. Now let's find the geometric mean between the first term and the fifth term. So we should get 12 as the answer. So the average of 1 and 5, 1 plus 5 is 6, divided by 2 is 3. So we should get A sub 3. The first term is 3, the last term, or the fifth term, is 48. Now, what's 3 times 48? If you're not sure, what you could do is break it up into smaller numbers. 48 is 3 times 16. 3 times 3 is 9, so you have the square root of 9 times the square root of 16. The square root of 9 is 3. The square root of 16 is 4. 3 times 4 is 12. So the geometric mean of 3 and 48 is the middle number in the geometric sequence, which is 12. Now sometimes you need to be able to write equations between terms within a geometric sequence. For instance, if you want to relate the second equation to the first equation, you need to multiply it by r. I mean the second term to the first term. If you want to relate the fifth term to the second term, you need to multiply it by r cubed. To go from the second term to the fifth term, you need to multiply it by r 3 times. If you multiply 6 by r, you're going to get 12. If you multiply 12 by r, you get 24. 24 by r, you get 48. So to go from the second term to the fifth term, you need to multiply by r cubed. And the reason why it's cubed is because the difference between 5 and 2 is 3. And you could check that. So if you take the second term, which is 6, multiply it by 2 to the third, that's 6 times 8, which is 48, and that gives you the fifth term. So if I want to relate the ninth term to the fourth term, how many r values do I got to multiply the fourth term to get to the ninth term? 9 minus 4 is 5. So I got to multiply the fourth term by r to the fifth power to get the ninth term. So make sure you know how to write those formulas. So we've discussed calculating the sum of a finite series. Just to review, if you want to calculate the sum of a finite series, one that has a beginning and an end, you would use this formula. Now what about the sum of an infinite series? How can we find that? What's the formula that we need to calculate s to infinity? It's basically this same formula, but without that part. It's a1 over 1 minus r. So here's two examples of an infinite geometric series. This is one of them, and this one is going to be another one. 8, 4, 2, 1, 1/2, and so forth. We can't calculate the sum of both infinite geometric series. For this one, r is 2. So r, or rather the absolute value of r, is greater than 1. When that happens, the geometric series diverges, which means you can't calculate the sum because it doesn't converge to a specific value. If you keep adding these numbers, it's not going to converge to a value. It's going to get bigger and bigger and bigger. So the series diverges. If you try to calculate it, let's say you plugged in 1 for a1 and 2 for r, it's not going to work. You get 3 over -1, which is -3, and clearly that's not the sum of this series. The fact that you get a negative sum from positive numbers tells you something is wrong. So this formula doesn't work if the series diverges. It only works if the series converges, and that happens when the absolute value of r is less than 1. If we focus on this particular infinite geometric series, notice the value of r. If we take the second term divided by the first term, 4 over 8 is 1/2. If we take the third term divided by the second term, 2 over 4 reduces to 1/2. So that's the value of r. So for that particular series, we could say that the absolute value of r, which is 1/2, that's less than 1. Therefore, the series converges, which means we can calculate a sum. It has a finite sum, even though the numbers get smaller and smaller and smaller. Now let's calculate the sum. So the sum of an infinite number of terms of this geometric series is going to be the first term, a sub 1, which is 8, over 1 minus r, where r is 1/2. 1 minus 1/2 is 1/2. So multiplying the top and bottom by 2, we get 16 on top. These two will cancel, we get 1. So the sum of this infinite geometric series that converges is 16. So that's how you can calculate the sum of an infinite geometric series. The series must converge, and for that to happen, the absolute value of r has to be less than 1. If it's greater than 1, the series will diverge, and you won't be able to calculate the sum. Now let's work on some practice problems. Write the first 5 terms of each geometric sequence shown below. So let's start with the first one. The first term is 2. To find the next term, we need to multiply the first term by the common ratio. The second term is equal to the first term times the common ratio. So 2 times 3 is 6. And then to get the third term, we just got to multiply the second term by the common ratio. 6 times 3 is 18. 18 times 3 is 54. And then 54 times 3, that's 162. So that's the answer for number 1. Now let's move on to number 2. The first term is 80. The common ratio is 1/2. So we're going to multiply 80 by 1/2. Half of 80 is 40. Half of 40 is 20. Half of 20 is 10. Half of 10 is 5. So those are the first 5 terms for the second geometric sequence. Now let's move on to number 3. So the first term is 6. To find the next term, we need to multiply 6 by -2. So this is going to be -12. -12 times -2 is +24. And then it's just going to alternate. So whenever you see a sequence, a geometric sequence with alternating signs, then you know that the common ratio must be negative. Number 2, write the first 5 terms of the geometric sequence defined by the recursive formula shown below. So we're given the first term. When n is 2, we have that the second term is equal to -4 times the first term. And we know that the second term is the first term times r. So therefore r, the common ratio, must be -4. So anytime you need to write a recursive formula of a geometric sequence, it's going to be a sub n is equal to r times the previous term, a sub n minus 1. The next term is always the previous term times the common ratio. So the common ratio is this number, -4. So once we have the first term in the common ratio, we can easily write out the sequence. So the first term is -3. The second term will be -3 times -4, which is 12. The third term will be 12 times -4, which is -48. The fourth term is -48 times -4, which is 192. And then the fifth term, 192 times -4, is -768. So that's how we can write the first 5 terms of the geometric sequence defined by a recursive formula. It's by realizing that this number is the common ratio. Write a general formula that gives the nth term of each geometric sequence, and then calculate the value of the 8th term of each of those geometric sequences. So let's start with number 1. So we have the numbers 6, 24, 96, 384, and so forth. The first thing we need to do is calculate the common ratio. So let's divide the second term by the first term. Dividing 24 by 6, we get 4. Now, just to confirm that this is indeed a geometric sequence, let's take the third term and divide it by the second term, not the first one. So 96 divided by 24. And that is also equal to 4. So we have a geometric sequence here. In order to write the formula, all we need is the value of the first term and the common ratio. So we could use this equation. The nth term is going to be equal to the first term times r raised to the n minus 1. The first term being 6, r is 4. So we can write it as a sub n is equal to 6 times 4 raised to the n minus 1. So this is the answer for part A for the first sequence. Now let's move on to part B. Let's calculate the value of the 8th term. So we just got to plug in 8 into n. So it's 6 times 4 raised to the 8 minus 1. 8 minus 1 is 7. 4 raised to the 7th power is 16,384 times 6. This gives us 98,304. So that is the value of the 8th term. And you could confirm it. If you keep multiplying these numbers by 4, you're going to get it. 384 times 4, that's 1536. That's the 5th term. If you times it by 4 again, you get 6144. Times 4, you get 24576. And then times 4 gives you this number. Now let's move on to number 2. So we have the sequence 5, negative 15, 45, negative 135, and so forth. So the first term is 5. The common ratio, which can be calculated by taking the second term divided by the first term, that's negative 15 divided by 5, that's negative 3. R is also equal to the third term divided by the second term, so that's 45 over negative 15, which is negative 3. So the value of the first term is 5, R is negative 3. So now let's go ahead and write a general formula that gives us the nth term. So a sub n is going to be a sub 1 times r raised to the n minus 1. The first term is 5, r is negative 3. So this right here is the answer for part A. Now part B, calculate the value of the 8th term. So let's replace n with 8. Negative 3 raised to the 7th power, that's negative 2,187. Multiplying that by 5, this gives us negative 10,935. So that's the final answer for part B. Number 4. Describe each pattern of numbers as arithmetic or geometric, finite or infinite, sequence or series. So looking at the first one, do we have a common difference or a common ratio? Going from 4 to 8, we increase by 4. From 8 to 12, that's an increase by 4. And 12 to 16, so we're constantly adding 4. We're not multiplying by 4. So therefore, we have a common difference and not a common ratio. So because we have a common difference, this is arithmetic, not geometric. We're dealing with addition rather than multiplication. Now, is this a sequence or a series? We're not adding numbers, so we have a sequence. If you see a comma between the numbers, it's going to be a sequence. If you see a plus, you're dealing with a series. Now, is this sequence finite or infinite? It has a beginning and it has an end. We don't have dots that indicate that it goes on forever, so this is finite. So we have a finite arithmetic sequence for number 1. Now let's move on to number 2. Going from 90 to 30, that's a difference of negative 60. Going from 30 to 10, that's a difference of negative 20. So we don't have a common difference here. If we divide the second term by the first term, this reduces to 1/3. If we divide the third term by the second term, that's also 1/3. So what we have here is a common ratio rather than a common difference. So the pattern of numbers is geometric, not arithmetic. We're multiplying by 1/3 to get the second term from the first term. Now, are we dealing with a sequence or a series? So we don't have a plus sign between the numbers, so we have a comma. So we're dealing with a sequence. And this sequence has no end. It goes on forever. So what we have here is an infinite geometric sequence. Now for number 3, we could see that we have a common ratio of 2. 5 times 2 is 10, 10 times 2 is 20, 20 times 2 is 40. So this is geometric. Now, there's a plus between the numbers, so this is going to be a series, not a sequence. And this series rather, comes to an end. The last number is 80. So it's not infinite, but it's finite. So we have a finite geometric series. For the last one, we can see that we have a common difference of -4. 50 minus 4 is 46. 46 minus 4 is 42. So this is going to be arithmetic. We have a plus between the numbers, so it's a series. And it goes on forever, so it's infinite. So we have an infinite arithmetic series. Number 5. Find the sum of the first 10 terms of the geometric sequence shown below. So the first term is 7. The common ratio, -14 divided by 7, that's -2. 28 divided by -14 is also -2. So now that we know the first term and the common ratio, we can calculate the sum using this formula. So it's the first term times 1 minus r raised to the n over 1 minus r. So the sum of the first 10 terms is going to be the first term 7 times 1 minus -2. Now it's raised to the n power. N is 10. And then divided by 1 minus r. -2 raised to the 10th power. That's positive 1024. And here we have 1 minus -2, which is 1 plus 2, and that's 3. 1 minus 1024, that's negative 1023. 7 times negative 1023 divided by 3, that's negative 2387. So that's the final answer. Try this problem. Find the sum of the infinite geometric series. So we have the numbers 270, 90, 30, 10, and so forth. So we can see that the first term, a sub 1, that's 270. The common ratio, if we divide 90 by 70, what does that simplify to? 90 by 270. Well, we could cancel a 0, so we get 9 over 27. 9 is 3 times 3. 27 is 9 times 3. So that becomes 3 over 9. 3, we can write that as 3 times 1. 9 is 3 times 3. This is 1/3. So that's going to be the common ratio. And of course, if you divide 30 by 90, you also get 1/3. So now that we have the first term and the common ratio, we can now calculate the sum of the infinite geometric series using this formula. It's going to be a sub 1 over 1 minus r. By the way, this particular infinite geometric series, does it converge or diverge? The absolute value of r is less than 1. It's 1/3, which is about 0.333 or 0.3 repeating. So because it's less than 1, the infinite geometric series converges. We can calculate the sum. The sum is finite. So let's go ahead and calculate that sum. The first term is 270. r is 1/3. So what's 1 minus 1/3? 1, if you multiply it by 3/3, you get 3/3 minus 1/3, which is 2/3. Now what I'm going to do is I'm going to multiply the top and bottom by 3. These 3's will cancel. So it's going to be 270 times 3 divided by 2. $270 divided by 2 is 135. 135 times 3, that's going to be 405. So that is the sum of this infinite geometric series.